Okay, let's take a look at an example of a binomial probability question. Instead of giving you the formula, let's try to figure out what the formula means, and then we'll make the general formula from it. A test consists of 12 multiple choice questions with 5 choices for each question. As an experiment, you guess on each and every answer without even reading the question. Hope nobody's been doing that. What is the probability of getting exactly 8 questions correct on the test? So let's see, we need to figure out a few things. The probability of getting an answer correct. Any one answer is 1 out of the 5, or 0.20, okay? So your odds of getting something incorrect on each one would be 1 minus that, or 0.80. So you got 20% chance of getting each answer right and 80% chance of getting it wrong if you're not even looking at the problem at all. So how we do the probability of this, and we're guessing 8 correctly, is we need to figure out how many possible combinations could this be. From 12 possible questions, we want to get 8 of them correct. So that's that formula that we were doing for combinations before. 12 possible choice questions, 12 possible questions, we want to get 8 of them right. Our probability, we have to kind of counterbalance this with its probability now. The probability of getting a question right is 0.20. And we want to raise this to the power of 8 because we want it right 8 times. But the probability of not getting it correct is 0.80. And we want that to happen 4 times. Now when we do this, you could do it separately in a calculator, but remember, I'm going to do this NCR, and I put in 12,8 in my calculator. And then I type in this, and you could do it all in one shot, or you don't have to. I got to go over that as my pen was running out. And when I type this whole thing in, you can do it by parts or not by parts. I'm getting the probability of this occurring. And it looks like it's not even a percent if I were to move the decimal place over. The probability of getting 8 questions correct on this test is so small. It's not even, 0.5 would be getting a 50% or 50% chance of this happening. Not even that. Nothing at all. Very closer to 0. So let me give you that formula in a standard sense. So the probability of getting a number, x being exactly something, we're going to call it r for right now. And what you did was you did n over r, just like in that last problem. Remember, n is usually the amount of trials or the amount we have to choose from, is the way I keep thinking of it. And r is how many we want. And we're going to do the probability of having that happen to the r, which is what we want. And the probability of that not happening is 1 minus. And this is where you're actually taking n minus r. I don't know if you realize, but you're taking the 12 and you took away the 8 and you're left with 4. Now, that's the way I think of it, but on your formula sheet, it's actually written out like this. P x equals k. Because remember I was saying before, they call this, instead of n and r, they call this n and k. This is not something you have to have memorized, because if you take a look, this whole formula in exact form is on the formula sheet, and it has the words binomial ahead of it and the directions above it. So you know that you can only use this when you have a binomial distribution. There is a way to do this in our calculator as well, and it is if you hit menu and you hit number 5, which was probability, and then you have to go over to number 5 again, which is distributions. And if you scan down, it's D, binomial PDF, it's called. And when I checked this in my calculator, I selected that and up popped this box. And it asked me some questions. It said, what is your N? And what is your, let me see, what is your N? So I put in 12 because I have 12 to pick from. It also asked the probability of a success, which was 0.20. And then it asked for the X value, and I wanted 8 correctly. So I plugged that in. And when I did that, it made it look like this. And it gave me this answer. So a good way to check in the Inspire calculator as well.